You know, I was here nearly 10 years ago, December of '99, when a spacecraft that really has the same origin, same similar design. Obviously, there's been a certain amount of upgrades because it didn't do so well in December of 1999. Mars polar lander came down. We don't know really what happened, but there are probably about 12 possible places which could have led to its demise. This spacecraft, which was its sibling, originally was canceled, but then they put it back on the racks and the testing boards and tested and retested it and flew the mission and proved that if you test a spacecraft, you got a better chance of surviving. That, folks, is not rocket science, but that is what has happened here. They learned a lesson, NASA did, about how much you cut the budget on a mission. That's why you're seeing these pictures tonight, and that's why we just saw within the past few minutes the first images from the Phoenix lander, the first images of Mars north of the Arctic Circle. It's a very different Mars. It's not your father's Mars. Take a look at this. You know, that's their first pictures. Joining us now, by the way, to walk us through this is Steve Squyres, who's the principal investigator for those plucky rovers that are still going on there. 4 years in the making. This is, you know, this is dull stuff, right? It's a solar array, but for the mission people, this is a big deal. There's a little bit of the turf there, a little bit of rock, but very different kind of terrain than you're used to. We see with Spirit and Opportunity. And then, of course, the solar arrays, all just the way they should be, all fanned out. That was a key thing, right?
That's absolutely essential. That is necessary for the vehicle to complete its mission because that's where the life-giving electrical power for this vehicle comes from.
All right, so solar arrays deployed, a picture off to the horizon which shows this tundra. And you could take a rover and probably put it in high gear in this place, but we were talking about it earlier, you don't necessarily need to rove.
No, in fact, you wouldn't want to. What you want to do in a place like this is dig. And that's the reason that this vehicle has this gigantic kind of backhoe arm that is in the days ahead going to scoop down into that soil and find out what's down below the surface.
That's about 2 days ahead. Let's go to the model and we'll talk about that for just a moment. It's actually, to be accurate, it's deployed. The cover it came with is off, which is a good sign. First of all, what they're going to do is focus on the camera. They'll swivel it around. They'll take a series of pictures. It's a stereo camera, so they can actually get kind of a three-dimensional feel of their surroundings. And they really want to know what's on the horizon in a 360 way, right?
They really want to do two things. First of all, they want to see out to the horizon so they can understand the geologic context, the setting in which they've landed. But crucially, they also want to be looking off on the north side of the vehicle, which is where they're going to dig. And they're going to use that stereo camera to make a detailed terrain map of the actual stuff that the arm is going to dig into in the days ahead. They kind of have to do that. The arm doesn't know where the ground is. They've got to tell it, and they need to take those stereo pictures to do so.
All right, so 2 days from now, if all goes well, we'll see those first digs, but we're going to get some more pictures as the night goes on, as they get more communications passes with the passing satellites. Suffice to say, I can't think of a thing that's gone wrong this far, and that's an amazing statement when you consider what's been accomplished.
It has been picture perfect. It really has.